Hi guys. Okay, so today we're here to look at something called trapezoidal approximations. Another way to estimate areas instead of rectangles. We saw when we used rectangles we had either a large overestimate or an underestimate. Well, a trapezoid would fix that. Now normally we see our trapezoids this way, and the area of a trapezoid is 1/2. The height would be this height. This is base 1 on top and base 2. Notice the bases are the parallel sides, right? But if we turn the trapezoid this way, the height here, that's the same as our change in x's on the base, and base 1 will be the function height on the left, and base 2 will be the function height on the right. Okay, so that's what we're going to try to do. So let's look at an example. So we're going to use 3 trapezoids. So we're going to do a trap sub 3, and f of x is 9 minus x squared, and we're only going to go from 0, 0, 1, 2 to 3. Okay, so if we think about the first trapezoid, it's going to go from 0 to 1. So our delta x is 1. That's our h. So we're going to have 1/2 times the height of 1 times, now the function, we're going to use the height on the left is 0 plus the height on the right is the function value at 1. So we are going to use the height here at 0 from the x-axis up, the height here at 1, the x-axis up, and then we're going to connect them with a trapezoid. And notice there's only a little bit of area we didn't get this time. Now the next trapezoid goes from 1 to 2. That also has a change of x is 1, and that's going to be our height. Now on the left side there is the 1, so we're going to use 1 to find the height, and on the right side is 2, so we're going to do f of 2 to find the height of that trapezoid. Now we already found the height at 1, we're going to draw the height at 2 here, and then we're going to connect it to make our trapezoid. Now the third one goes from 2 to 3, so our delta x again is 1, that's our height. And we have on the left, the x is 2, so we're going to use that function value, and on the right is a 3, we'll use that function value. And when we draw it, notice this time we really only have a triangle, because that height at 3 is 0. So we have here, let's see, 1/2. Now f of 0 is 9 minus 0, plus f of 1 is 9 minus 1, plus 1/2 times f of 1 is 9 minus 1, plus f of 2 is 9 minus 4, plus 1/2 times f of 2 is 9 minus 4, plus f of 3 is 9 minus 9. So we're going to have 1/2. And we're going to have a 9 plus 8. I'm going to factor out that 1/2, right? We have a 1/2 here, here, and here. Can I just factor that out? All right, and then I've got a 9 minus 1 is 8, plus 9 minus 4 is 5, plus 9 minus 4 is 5, plus 9 minus 9 is 0. So that gives me 1/2 times 35, which is 35 halves. If you want to divide it, it is 17.5, but the 35 halves is fine. And we're done. Ta-da! All right, let's try another one. Again, we're going to use 3 trapezoids to estimate the area between. Now this time our function f of x is negative x squared minus 2x plus 9. And we're going to do a trapezoid with 3 subintervals from negative 4 to 2. Now notice here, negative 4, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, okay? That is not going to be a change of 1 for the delta x's. So if you think about this, we have an interval that goes from negative 4 to 2. So I'm going to find the length of that. So when I minus a negative 4, that's going to be plus, and I want 3 intervals. So the length of our interval is 6, right? From negative 4 to 2 is 6 spaces, and I want to break it up into 3 parts, so that's 2, which is our delta x, which in this case is our 8. So we're going to go from negative 4 to negative 2, and then from negative 2 to 0, and then from 0 to 2, okay? So the delta x is 2. So for our trapezoid, it's 1/2 times the height is 2. Now, for the first subinterval from -4 to -2, we're going to use f of -4 plus f of -2, and we're going to find the height at -4. We're going to find the height at -2, and we're going to connect them for the trapezoid, and there we go. Now the next subinterval, again, we have 1/2 times the height, which is still 2. We're going from -2 to 0. So on the left, we have -2, so we're going to put that into f. And on the right, we have 0, so we're going to put that into f. And we're going to draw this. We have the height at -2. We need the height at 0. Oh, look at that. It's not a trapezoid at all. It's a rectangle. And then our third one, our third trapezoid, it's still a half. From 0 to 2 is a height of 2 or a change of 2. On the left, we're going to use f of 0. And on the right, we're going to use f of 2. So we have our f of 0. We have our f of 2. And we now have our trapezoid. And now we're ready for some computations here. So notice the 1/2 times 2 are going to be 1. They're going to cancel out. So that makes it a little easier. Now, f of -4 means the negation of 16 minus 2 times -4 is 8, so it's going to be plus 8. And then we're going to have a plus 9. Plus, now we have to plug in the -2. It's going to be the negation of 4. -2, that's a plus 4 plus 9. Plus f of -2 again, so that's another -4 plus 4 plus 9. Plus f of 0, that's easy, 0 minus 0 plus 9. Plus f of 0 again, 0 minus 0 plus 9. And then an f of 2 is the negation of 4 minus 4 plus 9. Okay, so what have we got here? That's 17 minus 16 is 1, plus those add to 0, so that's a 9. That adds to 0, so that's a 9. That's 9, that's 9. That's going to be -8 plus 9. And then this one is a 1. So when we add that up, these two are 18. That's 10 and 10. So that's a total of 38. And there we go. So a couple things to note. The height is the same as our delta x, so it's the length of the interval b minus a divided by the number of subintervals we want. And a nice thing about trapezoid is it's the average of the left ram plus the right ram. So if you know the L ram and the R ram, you can just add them up and divide by 2. Now another thing, trapezoid overestimates the area when the graph is concave up. It underestimates the area when the graph is concave down. If you think about it, if the graph is concave up, whether it's increasing or decreasing, a trapezoid is going to lie above it, right? And if the graph is concave down, whether it's increasing or decreasing, a trapezoid is going to lie below it, okay? So sometimes sketching it is actually better than memorizing. Now, the trapezoid method gives us the advantage of a better estimate, but the formulas are more cumbersome to use than the rectangles. So let's see if we can make this a little easier. So we're going to look at this function here. We have f of x is the negation of x cubed minus x squared plus 6x, and we're going to go from 0 to 2, and we want 4 trapezoids. So the first thing I'm going to think about here is that delta x, or our h, is going to be 2 minus 0 over, we want 4 trapezoids, so it's going to be 1/2. So even though we're going from 0 to 2, we're going to be using 1/2 and 3/2 in there. Okay, so we're going to write out a complete sum. So when we do this, the change here is 1/2. So what we have, a trap 4, we have 1/2 times the height 1/2. And then on the left we have 0, so it's f of 0, plus on the right we have 1/2, f of 1/2. Now we're going to draw our trapezoid, and it's actually not going to be a trapezoid, it's going to be a triangle because f of 0 appears to be 0. Now the next trapezoid from 1/2 to 1 also has a height of 1/2. On the left we have 1/2, so we put that in the function, plus base 2 is going to be f of the right endpoint 1. And we use our heights at 1/2 and 1, and make a trapezoid. Then for the next trapezoid, from 1 to 3/2 has a distance of 1/2. On the left is 1, we put that in the function. On the right is 3/2, we put that in the function. Plus, I'm going to use the height here. I'm going to bring this down. We have one more from 3/2 to 2, also has a delta x of 1/2. On the left is 3/2. On the right is 2. Okay, and I'm going to use that. Oh, look, another triangle. How nice. Okay, now I want you to look at what we wrote. We have a 1/2 in each term. A 1/2 times a 1/2. So we can factor out 1/2 times 1/2. Okay? That leaves us with f of 0 plus f of 1/2 plus f of 1/2 plus f of 1 plus f of 1 plus f of 3/2. And we have an f of 3/2 and an f of 2. So, now I want you to notice in the terms that we have left, f of 0 and f of 2 are used once, but we have 2 f of 1/2, 2 f of 1s, and 2 f of 3/2, because these sides are used in 2 trapezoids, whereas the first ones are only used in 1 trapezoid, okay? So that means we could rewrite this. 1/2 times 1/2 is 1/4. We have f of 0 plus 2 f of 1/2 plus 2 f of 1 plus 2 f of 3/2 plus f of 2. We could even go another step. Notice these 2's. We could rewrite this as 1/4 times f of 0 plus 2 times f of 1/2 plus f of 1 plus f of 3/2 plus f of 2. Okay, and now we can figure this out. 1/4, and if we look at our graph, f of 0 is 0 plus 2 times, if we look at our graph, f of 1/2, actually I'm going to use my calculator, f of 1/2 is 21/8 plus f of 1, I'm typing in my calculator, is 4 plus f of 3/2 is 27/8. Then I'm going to close this plus f of 2, again in my graph and my calculator, I know it's 0. Okay, so that's going to give us 1/4 times 2 times 48/8 plus 4. That's 1/2 times 6 plus 4, which is 10/2, or 5/2. Nice. So now a general formula. If we're looking for a trapezoid, we take the height and divide by 2. Whatever the first endpoint is, we put it in the function value once. We double all the other function values until the second to last one, and then add the function value at the right endpoint. Okay? Now what's really important to know, this only works if all the delta x's are equal. If they're not equal, they're not going to have the same h, you're not going to be able to factor it out, and it's not going to work. So let's look. This is the same problem we looked at the other day. The National Weather Service kept track of the rate of snowfall for our most recent snowstorm. The storm started at 9 a.m., which we represented as time t equals 0. The rate of snowstorm was recorded for every hour from 9 a.m. to 3 p.m. and estimate the amount of snowfall on the ground at 3 p.m. And this time we're going to use 3 trapezoids. So again, our delta t, in this case because it's time, or our h, is 6 minus 0, and this time we want 3 trapezoids, so we're going to have 2 for our height. So when we do this, our trapezoid of 3 is going to be the height 2 over the 1/2, or 1/2 times 2 if you prefer, and we're going with these subintervals, okay? So the first place we're finding the function value is 0. Now we're going to double. We're going to find the function value at 2. We're going to find the function value at 4. And now I'm closing that because the last one is 6. So at 0 and 6, we're only using the function value once in one trapezoid. So this is going to give us 1. F of 0 is 1, plus 2 times f of 2 is 1.4, plus f of 4 is 0.75, plus f of 6 is 0.25. So this gives us 1 plus 2 times 2.15 plus a 0.25. So that gives us 1.25 plus 4.3. That's going to be 5.55 centimeters. And there we are. Yay! Same problem, only this time we want 6 trapezoids. So our height this time, we're going to do these 6 minus 0. We're going to divide by 6. Now our height is 1. Okay, so this time when we do a trap sub 6, we have our height is 1. So 1/2 times 1. Now, we're going every subinterval now. We're going to use all those t-values. But the 6 and the 0, we're only going to use once. So f of 0 plus 2 times f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5. Close it because I'm done doubling. Plus f of 6. So we're going to have 1/2 of 1 plus 2 times 1.3 plus 1.4 plus 1.5 plus 0.75 plus 0.5, close it, plus 0.25. All right. So now we have 1/2. We've got 1.25 on the outside plus 2 times 1.3, 1.4 plus 0.5, 0.75, 5.45. Then if we double that, plus 10.9, that gives us 1/2 of 12.15 or 6.075 centimeters. So we've gotten closer and closer to the actual value. All right, guys. We're going to stop here. That's another way to find area under a curve. Have a good night.